Hello, chemists. We are talking about solutions this week. I have some objectives for you here. We're going to talk about strong and weak electrolytes. We're going to talk about solute and solvent. So we have some vocabulary for us. We're going to talk solubility a little bit more. We're going to talk about something unique about ionic compounds and the fact that they form precipitates. And we've talked a little bit about that. We saw a precipitate in lab when we got that very yellow solid. We're going to talk about how we measure the solute. We talk about concentration. We're going to talk about dilution and osmosis, a super important concept in nutrition and biology. A tiny bit of review for you to work on. I think that's really nice for you guys to sort of think through those things. Element versus compound, pure substance versus a mixture, and solubility as we know it so far. So those are good things to sort of start off with, and I'll give you guys time to kind of fill that in. When we talk about solutions, okay, we talk about, we've used this word mixture before, and so we want to sort of clarify mixtures can be classified as heterogeneous, and that word right there means different. Right, and so when you see a heterogeneous mixture, you might see like a chocolate chip cookie, where in that cookie you actually can see the chocolate chips, and maybe if you put nuts in your cookie, you can see the nuts. Maybe trail mix, where you can actually see the difference, trail mix, where you can actually see the particles, nuts and raisins and chocolate maybe, whatever you put into your trail mix. Maybe sort of a vegetable soup as well. Like when you look at a vegetable soup, you have the vegetables, you have the meat maybe. And, we may have talked about this a little bit too, where in a graduated cylinder, my great drawing of graduated cylinder, you might put, let's make this blue so we can put some water in here. Basically, we can put blue water in the bottom of a graduated cylinder, and then if we poured some oil on top, right, that oil might sit on the top and they would be separate, and that would be another example of a heterogeneous mixture, right? The oil's on the top, the water's on the bottom, and there's a distinct difference in that mixture. So a homogeneous or a homogeneous mixture is basically, that word right there means same, right? So it's the same throughout. Things like when you take that veggie soup and you whirl it in the blender and you make gazpacho, I don't know how to spell that, so I'm not going to write it down. When you dissolve salt in water, you can make a homogenized or homogeneous mixture. You've heard maybe of homogenized milk, right? We have another example of a heterogeneous mixture would be pulpy orange juice, right? Pulpy orange juice, where the pulp sits on the top, right? Or the milk that you buy from a local dairy, right? And then you have the cream on the top, right? And you can actually look at that mixture and see how it looks different throughout, right? Homogenized milk, we've actually sort of made the fat dissolve in the liquid, and so it's homogenized. It's the same throughout. We're going to focus on homogenized mixtures, and in chemistry we give them a special name. We call them a solution. And you've worked with several solutions in lab. You've done a saturated salt solution, right? We looked at that. Basically, we've worked with hydrochloric acid solution, where you dissolve hydrochloric acid in water. And you've probably made solutions in your kitchen before. Okay, so let's talk about those solutions and what their their components are. So basically, we've got the solute, and this is basically what's being dissolved. We can call it dissolved. We can call it the dissolvee, right? And the solvent is the dissolver. It's let me try that. It's what's doing the dissolving. What's doing the dissolving? Okay, so this might be the dissolver. Okay, to kind of put it in those terms. So what we like to think about is, generally speaking, the solute is in smaller quantities. okay? And usually, often, we use the word universal solvent for water. It's not always water, but water is often the solvent. And for most situations, in biology, in chemistry, or in nutrition, water is our solvent. And we've talked about the body a little bit and how it's a water-based system, and the fact that we have to put fats in that system is tricky, right? And so we have to there has to be methods by which that fat can be distributed throughout. Okay. So solute and solvent, the two components of a solution. So salt water, right? When we take salt and we put it in water, so we take NaCl and we dissolve it in water, right? We've got this solution, we've got this water in here, and then we've got these particles floating around in there, right? So we've got sodium particles and chloride particles. If we think about what that looks like, we'll talk a little bit more about that in a second. But basically, that's a good example of a solution where the salt is your solute and the water is your solvent. Okay. Other types of solutions. So if we talk about a solid liquid solution, this would be like salt water, right? Maybe you've made a simple syrup before and you've put sugar in water, right? That would be another example of a solid liquid solution. A liquid solution might be your rum and Coke, right? You dissolve a liquid, maybe you've done simple green, you've bought it and you've diluted it with water, right? So those are some examples of when you take two liquids and you mix them together. One of them is in a smaller quantity, that might be the simple green, right? And then the liquid that's in the greater quantity would be your solvent, that would be maybe your water. A gas liquid solution, so every time you drink any sort of carbonated beverage, you are drinking a gas liquid solution, right? And that bubble in there is carbon dioxide. Even like champagne, anything that has bubblies has carbon dioxide in it. So we've got this gas dissolved in a liquid. We like to maybe think about the fact that we've got oxygen dissolved in water, of course, in our lakes and streams, because we know that the fish are using that oxygen to breathe and it's dissolved in the water. So that would be an example. The air that we breathe is a good example of a gas mixture. It's primarily nitrogen. Of course, it's got carbon dioxide and water, oxygen and water vapor in it, and then it's got other stuff too. But it's a solution, it's a mixture of all these gases. Of course, the primary component of it is the nitrogen. That's what actually gives us the color of the sky. Solid solution is so like your gold ring, right? A gold ring, it's mixed up, so it's got gold in it, but it's got other metals in it to make it harder. Gold is a very, very soft metal, and so you mix it up with other things. And of course, you can mix it with different chemicals to make white gold, right? Gold, or rose gold is our kind of new thing that I've seen around, right? So solid solutions. Maybe so you can probably think of some other, but solid metals generally, like steel and those sorts of things, are solid solutions. Okay, we'll call that good and stop at this point. Just kind of an introduction to solutions. Again, I'd ask you to go back and maybe just think this through again so that you can take those concepts forward. These vocabulary words of hetero and homogeneous mixtures, and the idea that chemists like to talk about homogeneous mixtures as solutions with two components, solute and solvent. Okay, thanks for your attention. Hope you're having a great day.